Okay, in this video we are going to look at comparing linear equations. So we're going to look at parallel lines, perpendicular lines, and intersecting lines. So we have already looked at an equation like this. We've identified that this is the slope and this is the y-intercept. But now we're going to take one equation and compare it with another one. And depending on the equations and the graphs of those equations, we can determine whether lines are parallel, perpendicular, or intersecting. Maybe just a quick definition on what those are. So if you have parallel lines, these ones don't look like they'd be perfectly parallel. Maybe if I change it, maybe about like that. So parallel lines are lines that would go on forever and that they would never cross. Okay? Another way of defining parallel lines is that their slopes are the same. So if the slope is this one is, 10, this one would also be 10. So slopes are the same. Now, that's parallel lines. If you look at intersecting lines, intersecting lines are ones that will cross at one point or another. And if the slopes of two lines are not the same, they will eventually cross somewhere. So if the slopes aren't the same, then you're going to have intersecting lines. Now, the other possibility is if you have lines that look more like that. And these ones are perpendicular lines, where they cross at right angles. Often we put a little square there to indicate that that's 90 degrees or right angles. So the slopes of those two lines are similar. I guess they're not exactly the same, but there's a relationship between the slope of this line and the slope of that line. So let's look at those possibilities. So for the first one, parallel lines, the slopes are the same. Slopes of the first line are equal to the slope of the second line. For intersecting lines, the slopes aren't the same, so they will cross somewhere. Slopes of perpendicular lines are a little funny. It says here that the product of the two slopes is equal to a -1. So say, for example, the slope of the first line is 2/3. Then the slope of the second line, which is perpendicular to this one, would be, you'd flip that over, so it'd be 3/2, and you'd change the sign. So typically they call that the negative reciprocal. But if you take a look at those two numbers, if I were to take 2/3 and multiply it by -3/2, the 2's are a factor of 1, 3's are a factor of 1, so I'm going to get 1, and there's only one negative sign, so it'll be -1. So the slopes of perpendicular lines are ones that are the negative reciprocal of each other. Okay, negative reciprocal. Now the last one I didn't deal with on the last page, but the last thing that could happen if you have two lines, the equation of two lines, is that they could be the same line. So they're not parallel like this one or crossing, but they actually hit and they are the same line. And you know that if the slopes are the same, but that's sort of the same as the parallel, but in this case also the y-intercepts are the same. So if both of those are the same, of course it's the same line. If only the slopes are the same and the y-intercepts are different, then they're parallel lines. Let's try some examples. So here's three equations of lines, and I need to compare them. So are they parallel, perpendicular, intersecting, same line? What are they? To do that, you need to find the slope and the y-intercept for each. So this one's already in the right format, so slope is 1/2. Y-intercept -3. Okay, let's take a look at it's not in the right format. Okay, well let's take the x over. So it'll be -2y equals -x plus 6. We'll divide everything by -2. So divide by -2, divide by -2, divide by -2. I'm going to have to, I'll write it down here. So y is equal to negative divided by a negative is a positive. So that would be 1/2 x. 6 divided by -2 would be a -3. Okay, if I take a look at this one and this one, the slope is 1/2. The y-intercept is the same. So these two here are the same lines. So they're, I guess you could say they're parallel to each other, but it's the same line. Let's take a look at the one below. Same thing, we'll move the x over, so 2y equals negative x minus 6. Divide everything by 2 this time, and so I get y is equal to, this would be a negative 1/2 x minus 3. Notice the y-intercepts are the same, but the slope is different. Now, if the slopes are the different, then just automatically they're going to be intersecting lines. Like up here, we thought, well, perpendicular, maybe I could try that, but if the slopes are not the same, they're going to be intersecting lines. I guess we could prove that they're not perpendicular just by taking 1/2 and multiplying it by negative 1/2. If I come up to, like it says here, to negative 1 when you multiply the two slopes, then they're perpendicular. But you'll see here, one of these is negative, isn't it? Yeah. 1 times negative 1 is negative 1, 2 times 2 is 4. This is not equal to negative 1, therefore these aren't perpendicular. All they are crossing. Let's try another one. Okay, slope negative 3/4, y-intercept 7. Slope 4/3, y-intercept negative 9. Slopes aren't the same, so for sure they're intersecting. And let's just check to see if they are perpendicular. So to do that, I take the one slope, negative 3/4, and multiply it by the other slope. So negative 3 times 4 is negative 12. 4 times 3, oh, it's 12 as well. Simplify, that'd be negative 1. Therefore, this line and that line are perpendicular. Okay, getting on to the pattern here. Let's try another one. I just have another couple that we can try. Should I try that one? Sure, let's try this one. Move the 6x over. 2y equals negative 6x minus 3. Divide everything by 2. So this will be y is equal to negative 3x minus 3 over 2. I just sort of did that divide 2 in my head. You can write out another step if you want. Anyway, the slope is minus 3. Y-intercept negative 3 over 2. Let's check this one. I just have to divide by 12. So divide by 12, divide by 12, divide by 12. So y is equal to, that'd be 1/3 x plus whatever 4 will go into each of those. So 5 over 3. So the slope is 1/3 and the y-intercept is 5/3. Different slope, therefore for sure they're intersecting. And the only last thing to check is, are they perpendicular? So negative 3 times 1 over 3. I could put a 1 here. This is going to be equal to a negative 1. So they are intersecting, but they're also perpendicular lines. So that means that they would cross. Let's see what they look like. It'd be something like this one and something like that. So this angle here would be 90 degrees where they cross. Try another one. I just have to move the 3x over, so it'll be a positive 3x plus 1. This one I have to divide everything by a negative 2. Negative 2. So this would be y is equal to a negative 3/2 x minus 1. Okay, so slope on this one's 3, y-intercept's 1. Slope is negative 3/2, y-intercept's negative 1. Different slopes, got to be intersecting. Are they perpendicular? Well, 3 times negative 3 over 2, that's not going to give me negative 1, right? Not going to be negative 1. So they're not perpendicular. Of course, they're not parallel because the slopes aren't the same, but they are intersecting lines. Here's just a bunch to try, and maybe you can try these, or you can try some from the textbook. But basically what you have to do is take any equation that isn't in the y equals mx plus b form. So like this one, I've got to take that and make it look like that. And then from that, draw out my slope and draw out my y-intercept. When I do that, I could have 4 things that happen. If the slopes are the same, then it's a parallel line. If the slopes are the same and the y-intercepts are the same, not only are they parallel, but it's the exact same line. If the slopes are not the same, by default, they are intersecting. And if they're intersecting and the slopes, the product of the two slopes is -1, then you have perpendicular lines. Okay, try some of those questions on that. Hope that helps.